Hello everyone! I would like to show you how to set up an Olympus microscope according to Köhler. This video shows the Olympus CX31, but all the other Olympus microscopes have the same functional elements. At first, I would like to show you the basic elements of the microscope. Here you can see the binocular tube with the eyepieces, the lens turret with the objective lenses, and the microscope stage with its specimen holder and its adjustment knob for the movement of the stage. This is the main switch and the light intensity control knob. This is the focusing drive, the condenser with aperture diaphragm and the field iris diaphragm. Now I would like to show you how to set up the Olympus microscope. At first, swivel in the correct objective and make sure that the label of the objective fits to the label of the condenser disc. Now check the light intensity and put a sample into the specimen holder of the mechanical stage. Then turn the knurled knob for vertical adjustment of the condenser to the top stop. Now focus on the sample by using the focus drive. Next, close the field diaphragm enough to make it visible in field of view. Then lower the condenser until the edges of the field diaphragm appear sharp. Now center the field diaphragm image with both centering screws on the condenser carrier. Open the field diaphragm enough to make the edge of the diaphragm disappear from the field of view. To adjust the aperture diaphragm, set the condenser to bright field and take an eyepiece from the tube barrel and look through the barrel. In order to achieve a perfect image quality, the diaphragm opening should generally be open 70 to 80% of the objective lens aperture. Now switch the condenser back to the appropriate phase. In the next step, the microscope needs to be set up for the phase contrast. The phase contrast is required for the imaging of low contrast structures like sperm cells. The phase contrast has to be adjusted for every phase contrast objective separately. To adjust the phase contrast, swivel the objective into the beam path and turn the condenser's revolver disc to the same label. Remove an eyepiece from the tube and replace it with an auxiliary microscope. Use the adjusting fixture on the auxiliary microscope to focus the annular diaphragm and the phase ring. Use the two screws on the back of the condenser. Now you have to achieve a full overlap between the lighter annular diaphragm in the condenser and the darker phase ring of the objective. When done, repeat this procedure with all other phase contrast objectives and then replace the auxiliary microscope with the regular eyepiece. These adjustments are required whenever a new microscope is set up. Additionally, it is sometimes necessary to readjust the microscope settings, for example when the microscope has not been used in a long time or when it has been placed somewhere else. Please be aware that these adjustments are crucial for a proper semen analysis. This is how a picture looks like whenever the condenser is not correctly centered. The light in the picture is not distributed evenly. This is how the sperm cells look like if the phase contrast is not adjusted properly. The cells don't look as bright as normally and everything appears grayish. If this is the case, please readjust the phase contrast correctly. This is how an optimal microscopic picture should look like. All semen cells appear fully white on a black background and the light is distributed evenly on the picture. What to do when no picture is visible? Please check if the condenser is at the right position. This is normally almost the top stop. Check if the right objective is swiveled in correctly. The label on the objective has to fit the label on the condenser disc. What to do when the microscope had been adjusted properly, but the picture still appears grayish and unfocused? Please clean the objective lens as well as the condenser lens. Especially extender residues can affect the picture. Please clean first with a microscope tissue and hot water to dissolve the sugar contained in the extender. and next with a microscope tissue with alcohol for a clear picture.